In this mathematics video lecture, we consider a concept that is extremely important, and probably the best way to introduce it is to look at something practical, uh, something I think which everyone is familiar with. If you consider in physics speed, when we talk about a speed, we mean how fast an object is moving. So we consider a car moving at a speed of, okay, let's keep it within speed limits, 100 kilometers per hour. Now, imagine you on a road and you see a car approaching you. And this car is approaching on your right. So you look to the right and you see the car and it speeds past you at 100 kilometers an hour. Then a minute or two later, you notice a car approaching from your left. So you look to your left and you notice that car also passes you at 100 kilometers an hour. But either car, you will still refer to the speed as being 100 kilometers an hour, irrespective of the direction from which it approaches. And that is really the context of magnitude. In mathematics, we're going to call those the absolute values. So in our example, with the speed of a car, it doesn't matter in which direction, from behind you, in front of you, from the right, from the left, we will say that the magnitude or the absolute speed of that car approaching you is 100 kilometers an hour. Now, all that we are going to do is look at the mathematical syntax that we are going to use in order to capture magnitude or absolute values. So absolute values, we are talking about the magnitude. Also, many textbooks refer to it as the modulus. So let's get down to how we would do this mathematically. Consider our number line here. Right, so there is our 0. To the right, we've got positive values, 1, 2, 3, 4, to infinity. To the left, we have our negative values, -1, -2, -3, -4. Now, if I look at the number 4, I notice that the distance from 0 to 4 is 4 units. But I can do likewise with -4. From -4 to 0. That distance, the distance, its magnitude, is also 4 units. So irrespective of whether I look at +4 or -4, the distance from 4 to 0 is 4 units. The distance from -4 to 0 is also 4 units. And that's where we introduce the concept of absolute values. And the notation that is going to be used is 2 vertical lines. Okay, let's get back to our red. We're going to use 2 vertical lines to indicate we are dealing with an absolute value. So the absolute value of 4, when you see that, that actually means, tell me, what is the distance from +4 to 0? It is 4 units. And when you see this, that means what is the distance from -4 to 0, it is also 4 units. And that is known as the absolute value of whichever number you are looking at. So for example, if I have to tell you what's the, okay, look, I've got some numerical examples at the bottom here. What's the absolute value of 25? What is the distance from 25 to 0? It is 25. What is the absolute value of minus 3.14? It is 3.14. What's the absolute value of 6? It is 6. So there we have some numerical examples, and I don't need to go on, irrespective of what we do. What is the absolute value of negative pi? It is pi. So those vertical lines indicate that you're dealing with the absolute values. Now notice the absolute values answer will always be positive. Now, how do I capture that concept and my discussion now mathematically? Here we have the definition of absolute values. F of x is equal to the absolute value of x. And the absolute value of x is equal to negative x when we look at x less than 0, and x if we look at x greater than or equal to 0. Now, at first, that seems a bit confusing because there's so many x's there. But this is your restriction. These are your restrictions coming directly from there. So in other words, this, let's look at the bottom one first. This says if this x here is greater than 0, then the answer is just plus x. So for example, if I ask you what is the absolute value of 1212, that is the x. That is the x we're talking about. It is greater than 0. It is greater than or equal to 0. Therefore, it's just equal to the plus of 1000. In other words, it's 1212. In the top case, if you consider minus 5.27, then this x here is less than 0. Then my answer will be minus whatever I see in between the absolute values. So it would be minus 5.27, and that will just equal to 5.27. In other words, a positive answer. Now, oh yes, okay, let's just get this out of the way. I tend to do that. 5.27, 5.2. I will try to always remember to use our points. Minus 5.27. Now, in many cases, when it comes to numerical values, we don't normally do this. We just give the straightforward answer, 5.27. So there, in essence, is the definition of absolute values. It's the concept of absolute values. This is something you must always bear in mind. Okay, what about some of the properties that we'll come across with absolute values? Now, I'm going to go through these properties. We're going to possibly use the properties, but we won't specifically question on the properties themselves. But you will see that the properties are, in many cases, self-evident. So firstly, the absolute value of A, where A could be any number, absolute value will always be greater than or equal to 0. We just did examples right now. Irrespective of what is between the absolute value minus a half, the answer is plus a half, which is greater than or equal to 0. So that's property number 1. The other properties essentially gives you an idea that they are related, in fact, to the algebra and the operations that you've built up over the years. For example, the absolute value of A times B. This you can split into saying that is equal to the absolute value of A multiply by the absolute value of B. So what do I mean by that? Let's say I give you the absolute value of 3 times x plus 1. That can be split up into the absolute value of 3 multiplied by the absolute value of x plus 1. And of course, that can be extended to division as well. The absolute value of A over B, I can split it to the absolute value of A divided by the absolute value of B. I don't think there's need to give an example over there. Now, the fourth one is a property that is used extensively, especially at physics, postgraduates and so on, where they look at quantities that are either added or subtracted. So the absolute value of A plus or minus B is less than or equal to the absolute value of A plus or minus the absolute value of B. In other words, it's not straightforward with addition, subtraction. With multiplication, division, that's fine. But addition, subtraction, not so. I mean, look at this example. If I tell you absolute value of minus 5 plus 7, okay? If you go between the absolute value sign first and you add minus 5 plus 7, that's going to give you, absolute value is going to give you 2, and the absolute value of 2 is 2. But now let's split them. The absolute value of minus 5 plus the absolute value of 7. Now the absolute value of minus 5 is 5. The absolute value of 7 is 7. And that gives you what? 12. So you can't just say these are equal. They're not at all. This is less than the 12. And in some cases, if I take specific values, it could be equal. So that is a very important property of absolute values, that the absolute values of A plus or minus B is less than the absolute value of the individual terms added. The absolute value of A plus or minus the absolute value of B. Now, number 5 is also another important property that you should know. The square root of A squared is actually the absolute value of A. Now, you can investigate that and you can work that out. And you'll find that the square root of A, irrespective of what A is, will give you the absolute value of A. Okay, some very straightforward properties. We're going to apply some of those properties in absolute value equations. And this is what we are going to concentrate now on, is when we obtain absolute value within an equation, how do we go about solving that? So the procedure. Now, the first one I'm going to look at is equations, the equal to sign. And if you look at a simple example, let's say I give you the absolute value of x is equal to 8. What numbers that can I substitute here that will give me 8 as an answer? Well, that x could be either plus 8 or it could be minus 8. So there are your two answers. When you get an absolute value equation, in other words, with the equal to sign, then we can apply a simple procedure. We can drop the absolute values and say that whatever is between the absolute value is equal to the positive of the right-hand side, or it's equal to the negative of the right-hand side. However, please bear this in mind. only do that when you have isolated the absolute value on one side of the equation. So isolate the absolute value. Now, what do I mean by that? In other words, if we get any values outside of the absolute value, we can use the properties where we simply have to transpose and divide to eventually arrive at an absolute value all by itself on one side of the equation. So the procedure then is very simple. If I have an absolute value of x minus a equal to t, then I drop the absolute value and say whatever's between the absolute value is either equal to the plus of the right-hand side or the minus of the right-hand side, and then you can transpose and work it out. So let's do these. Number one, the absolute value of 3 plus 2x is equal to 11. And look, we can consider going back to the actual definition and talk about distances, but it becomes a bit cumbersome. So if we can apply this procedure, it will make it a lot easier. So firstly, is the absolute value isolated? Yes, it is. There's no number before. Well, there is, and that's 1. And there's no term that I need to transpose. So the absolute value is isolated. And because this is an equal to sign, I drop the absolute value as equal to plus the right-hand side, or drop the absolute value equal to minus the right-hand side. There you get your two possible answers. Transpose, work it out. Here I get x is equal to plus 4. Here I get x is equal to minus 7. And then you can check. You can check these, which you have to do. Substitute 4 into the x. 2 times 4 is 8 plus 3, 11. Absolute value of 11 is 11. And also do likewise for minus 7, and you'll find we can accept both of those as answers. Now, number 2. I just want to see, okay. Number 2. The absolute value of x plus 5 divided by 2 minus x is equal to 6. Now here again, because both the numerator and denominator lie between the absolute value signs, there's nothing to transpose, nothing to divide, which means I can apply this procedure immediately. So I drop the absolute values, and that's equal to the positive, or drop the absolute values equal to the negative. So I generate two equations and then you solve. Normally, this is not an inequality, it's an equal to sign. So I can cross multiply 6 times 2 minus x. And then here, you can work this out and double check. I get x equal to 1. On this side, x plus 5, negative 6 times 2 minus x. Here I get x is equal to 17 over 5. But most important, why is there restriction? Because of the denominator. The denominator must not equal to 0. In other words, x must not equal to 2. But when we check our answers, we notice there's no 2. Therefore, I can accept both those answers. There's straightforward equations. Now, the third one, a bit more in depth, and why? Look at the first example, the second example. The absolute value and the variables. The variable was between the absolute value, but only on one side of the equation. Whereas in number 3, not only do we have x between the variable, but we also have x outside. Not only do we have the variable x between the absolute values, we also have x on the other side of the equation without any absolute values. Now, how do we go about solving such an equation? In number 3, let's have a look at it. So we have 2x minus 7 is equal to the absolute value of x plus 1, and we want to solve this equation. Now, when you have the variable on both sides of the equation, then you will divide this into 2 cases. Case number 1, and this is taken directly from the definition. I'm just going to go back to the definition so you can see exactly what I mean by that. There's the definition there. And those are your 2 cases. The first case is the x, whatever is between the absolute value must be greater than or equal to 0. That gives you the 1 equation. Then when it's less than 0, it gives you the negative of it. So let's apply that definition. Let's see how to do it. So how do we do it? Case number 1. This is when whatever is between the absolute value must be greater than or equal to 0. Let's just solve that quickly. Okay, so that's the restriction, that's the condition. And when x is greater than or equal to 0, we know that, of course, to be positive. Then we drop the absolute value, and it will be equal to the positive of the other side. That's case number 1. Now, I can solve that, but I prefer showing you the case number 2 immediately. In case number 2, we're going to have x plus 1 less than 0. In other words, the negative. And there we can transpose x is less than minus 1. And when we have x plus 1 less than 0, then we drop the absolute values, and that will be equal to minus, that will be equal to, negative of the other side. So it's negative, open brackets, 2x minus 7. Then, of course, you simply solve each case. So solving the first case, you're going to get transpose here. You get x is equal to 8. Solving the second case, minus 2x plus 7 is equal to x plus 1. Transpose minus 3x equal to 6. Divide, I get x is equal to 2. So now I have 2 possible answers, x equal to 2 and x equal to 8. However, they must satisfy that condition for each case. So does x equal to 8 satisfy the condition x is greater than or equal to minus 1? Yes, therefore x equal to 8 is an acceptable answer. What about the second case? X equal to 2, does it satisfy the condition that x is less than minus 1? No. Therefore, x cannot be equal to 2, which means x equal to 8 is the only answer, a single answer in this case. And those are your absolute value equations. Now, just like normal algebra, like you did at school, not only do you get equations, you also get absolute value inequalities, the less than, the greater than, the less than or equal to, the greater than or equal to. Now, in this case, we have our two cases. Oh, in this situation, we got either the less than or or equal to. Then the second case, the greater than or equal to. Now, you would notice that in the procedure for solving absolute value equations, the sort of key step is to try and drop the absolute value. And when we drop the absolute value, then we have to consider what we need to do. Now, I'm not going to look at the actual number line, but just quickly, if we have that as A and X is somewhere over here, then that there would be our T. So we want to find the X here that is less than or equal to T. And of course, it can be on the other side as well. Now, you can have a look at many of those videos online or in textbooks. I'm just going to go directly onto as to how do we go about solving an inequality that has a less than sign. And the situation is very clear. I'm going to do that one only. All you have to do when it's a less than sign, then you drop the absolute value and you say it's less than the positive of the right hand side or greater than the negative of the right hand side. In other words, you generate a double inequality that you can solve. Of course, if it's an equal to sign, then that will just become an equal to sign. So not much in terms of a skill or theory. This would be the actual concept, but the actual procedure to do it is actually very straightforward. Drop the absolute value sign when you have a less than, then it's less than the positive or and greater than the negative. What about the greater than sign? When X is greater than T, then we're going to drop the absolute value sign and say greater than positive. But now we're going to separate it and we're going to use or. X minus A less than the negative of the right hand side. Right, so look at that again. When you have an absolute value inequality that has a greater than sign or a greater than or equal to sign, then you drop the absolute values and you say whatever is between the absolute values is greater than the positive of the right hand side, or whatever is between the absolute values is greater than the negative of the right hand side. Now we're going to look at some quick examples. So let's take X plus 3 less than or equal to 3. Okay, I'm just going to change this, otherwise we're going to get a 0 there. I'm going to make that X plus a 2 less than or equal to 0. Apologies there. So this is an inequality. The first thing I must look at is making sure, let's rewrite that, the absolute value of X plus 2 less than or equal to 3. First check, is the absolute value isolated? Is it by itself on the one side? Yes, it is. Do I need to transpose or divide? Not at all. Once I have done that, then I check the inequality. This is a less than or equal to sign. So I drop the absolute value. It will be less than or equal to plus 3, greater than or equal to minus 3. There's a double inequality. Transpose and work it out. I transpose on both sides. Take the 2 over there. 3 minus 2, that gives you 1. Take the 2 over there. Greater than or equal to minus 5. And there's your solution. And you can take those values and check. Any values between. Let's take a value, for instance, 0. If you put 0 over here, 0 plus 2 gives you 2. 2, the absolute value of 2 is less than or equal to 3. Interval notation. Let's just indicate our interval notation as well. Using brackets, it's square brackets because the n values are included. There you go. There's our interval notation. Okay, solve for x. Number 2. Minus 2 times the absolute value of 2x plus 3 plus 14 greater than or equal to minus 16. Now, remember what I said. The first thing to do is not to look at your signs, rather to check whether the absolute value is isolated on the one side. Now we notice over here it isn't. So before I can actually apply the different cases, I'm going to have to manipulate it, use my techniques of solving of transposition to isolate the absolute value. So let's see, first the 14. So I'll leave the minus 2. Take the 14 across, minus 16 minus 14. Although I'm showing all the steps, you don't need to, of course. I'm just making sure that you understand what I'm doing. So that gives me negative 30. And now I'm going to divide by negative 2. Now, what did we say before? When we divide by negative, what's going to happen to the inequality? It's going to change direction. Therefore, I get 2x plus 3 less than or equal to minus 30 divided by 2, 15. And that is the reason I say, first check that the absolute value is isolated on the one side. Now I can use the second case, sorry, the first case. For less than, I can drop the absolute values, is less than or equal to positive, greater than or equal to the negative, transpose, divide. So I get 2x less than or equal to 12, take the 3 over, minus 18, x is greater than or equal to minus 9, less than or equal to 6. In interval notation, minus 9 and 6. So that's solution of absolute value inequalities. We just got one more to solve. Let's have a look at this. Solve the absolute value inequality. 2 times 3x minus 12, so I get 2 times the absolute value of 3x minus 12 greater than or equal to, again, there's a mistake here, but we'll leave it, 13. Isolate the absolute value, so I'm going to divide by 2, so I get the absolute value of 3x minus 12 is greater than or equal to 13 divided by 2. Now, the inequality is greater than. So with this, let's just recall, what do we do with the greater than? There you go. With the greater than, you drop the inequality greater than the positive, or drop the inequality greater than the negative. So let's apply that. 3x minus 12 greater than or equal to the positive, or 3x minus 12 less than or equal to the negative of 13 over 2. And we can simply transpose and divide. So there I have 3x greater than or equal to 13 over 2 plus 12, which is 24 plus 13. Well, that's 13. Three x is greater than or equal to 37 over 2. X is greater than or equal to 37 divided by 6. Or in this second case, 3x less than or equal to minus 13 over 2 plus 12. 3x is less than or equal to, that's 2, 24 minus 13. Okay, getting back to that, that's minus 13 plus 24. Minus 13 plus 2 times 12, that's 24. That gives you 11 over 2. X is less than or equal to 11 divided by 6. And there is your two answers. Now, what I'd like to do here is to write this in interval notation. We have two values. One is 11 over 6 and one is 37 over 6. Now 11 over 6 less than 11 over 6 is the smaller value. And it goes from 11 over 6. And 11 over 6 is not included. Going to infinity. That's this answer here. Or 37 over 6. And that goes to plus infinity. There's your interval notation for these answers. Right. The last step is the absolute value graph. Now, let's just quickly recap. The function f of x is equal to the absolute value of x. And that is equal to, by our definition, is equal to x when x is greater than or equal to 0 minus x when x is less than 0. What this has done now is divided the Cartesian plane into two parts. The first part is the case where x is greater than or equal to 0. Now, let me just try and get this as straight as possible. There you go. There's 0 here. Now, greater than or equal to 0 means we're dealing on the right-hand side of the y-axis. And then the line for the right-hand side is f of x equal to x. So I'm just going to write it here. In other words, y equal to x. When x is less than 0, then f of x is equal to minus x. And I'll write it here, y is equal to minus x. So in other words, I draw the line y equal to x when x is greater than 0, and the line y equal to minus x when x is less than 0. What does the line y equal to x mean? The line y equal to x is that straight line having an angle of 45 degrees. That's the line y equal to x. However, I must only see it from here to the right on the positive x values. So I'm going to have to erase this part there. Then the second case, in the restricted domain, less than 0, we have to draw the line y equal to minus x. And now we have to stop here because we can't go beyond that point. Beyond 0 is positive values. Beyond 0, these are plus values. That is where x is greater than or equal to 0. Over here is negative values. This is where x is less than 0. And there you go. This is the graph of the absolute value. Y is equal to absolute value of x, like a V shape. The variations we'll do at a later stage. Okay, that brings this to a close. Let's exit here.